Hello YouTube. So today's video is going to be about RAM, or random access memory, particularly SRAM, which is static random access memory, and how you could use RAM on a very low level to implement in circuits. So this is the circuit which I have right here. This chip right here is a 64-bit RAM, which is 4 bits, and it has 4 address lines, so in total you have 64 bits of storage. And this other chip is a hex inverter, because some of the output lines on the RAM chip are inverted, so you need to invert them again in order to drive these LEDs. And I also have this board, which is for the inputs. These are the address lines, these are the data lines, and also I have memory enable and write enable to drive the RAM chip. So this is a pretty messy bunch of wires. So let's look at these schematics to see what's going on. So as you can see, what I'm using here is the 74189N tri-state RAM. I got it from Jameco Electronics. If you want to get it, the same one, here's the data sheet, you could look it up. And it has, so you could see that it has your memory enable, your write enable. You have 4 data lines, 4 of these S lines, which are the output lines, and you also have 4 address lines. So how we actually wire them is the address lines they're wired pretty simply. You have to pull them down to ground, which I'm doing with these resistors, and then basically you could just switch them to 5 volts to change the address. Same for the data lines, as you can see as well. And the S lines, they have to go to inverters first. So as you see, they go to inverters and then they go to LEDs, to resistors, and to ground. You also have memory enable and write enable. This is where it kind of gets a little interesting, is that your write enable, it has to go to 5 volts is what you're switching, and it's normally tied to ground, whereas your memory enable is the opposite. And basically how we're doing it is, here's your truth table and some other stuff which I wrote down. So you basically want to make it so when I'm not pushing either of the buttons, it's holding, so that way it's not constantly writing whatever in the data lines to the location represented by whatever is in the address lines. So how it is right here is it's just holding, and when I press down memory enable, I could write, and when I press down write enable and then memory enable, I can read. And that's important that both of them are pressed down, but I want to press down write enable then memory enable first to prevent it accidentally writing to it, which is something that I found out. If you are driving this using circuitry, you might want to implement that, or maybe it would work at the same time. I don't know. I've just been testing it manually to see how it works. And here's some other things which I thought about was one thing I want to use this for an 8-bit computer using a Z80 CPU. I have the CPU over there. It needs RAM. Here's some RAM right here, so I could use that. Well, it needs 8 bits of data lines, so I could just tie the address lines of 2 RAM chips together, and then basically you have 8 data lines split among the 2 chips. And then I was also thinking about, well, the Z80 has way more than 4 address lines. It has 16. Some of those you would use for ROM, some of those you would use for I/O, but you probably would want a significant more of them than just 4 for the RAM. So I've been trying to make some kind of circuit. You can see this one just using AND gates. So your additional data line, it'll go through an inverter for one of them and not for the other one. So either one of these will be active. Though I'm not really certain about this, I'm thinking about just using a multiplexer chip for however many data lines which I want to have, if that makes any sense. So let's just demonstrate this circuit. So let's go to address 0. So I pull down these and let's see, we're going to do write enable then memory enable, and you can see that's what's in the address 0. So let's change it. Let's try to make it something else. So let's just do 1 and we're gonna write it, and now we're gonna read it. And oh look, the red LED is 1. Yes, I know these are the most significant bit is backwards, so I guess you could deal with it. So now let's go to address 1. We were at address 0, so let's put 3 in address 1. So first of all, let's see what's there. Okay, it's that. Now let's write our new data, and then we can read it. Oh look, 3. It used to be 2. And of course we could go back to 1, and then we could read it as well, and it's still 1 at address 0. So of course we have 4 bits, so we could go to address, let's go to address 8, 9, 10, and let's see what's there. What's in address 10? 2. Okay, we're at address 10, so what do we want to be in address 10? How about 9? And let's write 9 to address 10. And let's see if it's there. Oh look, 8 and 1, that's 9. So yeah, I've been doing some experimentation. If I could talk correctly, I've been doing some experimentation with this RAM chip, this 4-bit RAM chip. It is 4 bits for address lines. They call it 64 bits. I think that's a bit misleading, but oh well. So yeah, so what I'm going to try to do is I'm going to try to make a larger circuit using these. I'm probably going to need a lot more of these inverter chips as well as a multiplexer as I previously described. And I want to try to make some kind of computer circuitry using a Z80, which is here. The Z80, of course, you have your 16 address lines, so that's going to take quite a lot of RAM chips. Also, I have this right here, which is in ALU, a arithmetic logic unit. This would be part of a CPU. So if I wanted to make my own CPU, I would use this instead of just using the Z80, which is probably what I'm going to do first. Then I'll make something with this. Also, I have this right here, which is going to be a 555 timer to provide the clock to Z80. So I'm just laying everything out right now for a computer. And yeah, so this video is on the RAM chip. I'll make more videos soon. If you want to see the schematic, here you go. And I will see you in the next video. So see you next time.